Sorry.
Okay. So again, a quick and easy guide to speeding up MySQL for website development. So this is what we're going to talk about. So basically, we're going to talk about data types. Then, sorry, we're going to start with actually monitoring. Then data types, engine types like MySQL or InnoDB. Some MySQL internal, some applications, some and at the end, which is the part I like to spend the most time, is the application side, things that you could do, have more control over to speed up MySQL. So, yeah, just continue.
You like to tell us to do that all day long, don't you?
Mm-hmm.
Okay, so presentation for developers who tune up MySQL when they really have to, basic steps and good practice for using and speeding up MySQL so that MySQL will work better for you. 90% of the reason why MySQL is slow is due to bad schema design, or in other words, how the database is set up versus how you use it. And MySQL is fast, no really it is. It just needs some attention every now and then. Oh, by the way, I forgot one thing. So here, like, from your point of view, the monitoring is like a little bit boring. The data types is somewhat boring. Engine types is again somewhat boring. MySQL internal is really boring. Replication is boring and confusing at the same time. And the application side is, I'm sure you all enjoy a lot more than the others. So monitoring, actually should have been monitoring and benchmark. Oh, we do have benchmark. Okay. So we use Nagios here. I have an example here to monitor MySQL. It's open source. You can get it. There's a plugin for MySQL. I think it's a bit difficult to set up, but once you do it, it's quite okay. And what you can't measure, you can't actually improve. So we have a view of Nagios. Oh, okay. So I tried to find one without any red ones, but I just couldn't do that. I got you the closest thing. This is one of our one of our databases. This is actually performing relatively well, I would say. Although Nagios doesn't say that. So basically, you have here all sorts of things. What you should basically look for is, even if you don't understand everything that's here, go over the red parts and take it quite seriously. So I think right now we're not using this database, maybe that's why we have all the red parts. Some things to look for also, obviously, is like the query cache we have here and things like that. But basically, I'm not going to go too much into detail, but if you have red parts, then you know what to improve. So it doesn't necessarily mean you have to know everything about MySQL. But if you use some kind of monitoring tool like this and it shows this is bad, this is slow, at least you have something to go on. A really big reason why also I think a lot of servers are slow is this one here. It's 50% of this many 10 tables were created on this, which I'll speak quite a lot about in this presentation. This is something to watch here. So, continuing. Okay, more expensive. Okay, that one I didn't prepare. One second.
So is Nagios monitoring a database or is Nagios monitoring a server?
It can do both. So it has a plugin for the actual database, like so actual server like CPU. I don't think disk, but like things like that. Then you have another plugin for MySQL. So it has lots of plugins. Let me just try to get something here.
I think out of the box it just gives you default stuff like is the server up, is it responding to ping?
You can do disk space and stuff,
Yeah, disk space, things like
and you can write your own.
Oh, okay. I should have given some examples, but I didn't. Let's see. So, okay. So we have here explain. So basically, explain select what it does is you have your select statement, and what it does is it tries to explain to you how it gets to that, how many things it gets to. So for example, select star from all those. What it will show you is it doesn't give you any data to show you what it does. Okay, so we have actually minimize it a bit. We have so basically every time you do this select, if you don't do a work close, it will go through this many rows, 1,000,000, 100,000, this many rows. Doesn't use any index, so this is basically a full table scan. Will be the slowest possible option. Okay, let's try to do inner join. Again, I apologize for not doing this beforehand. All the details. Pretty. It's actually meaning like this. All the details. ID equals ID. Pretty basic, right? I'm sure people can follow up, right? They can keep up. Okay, and we do this explain statement, and what it does is it shows us. So we're doing again a full table scan because we haven't done any well, for example. But every time we have like a row. Or every time we query the second table in the inner join, the oldest table, we only need to look up one row. Okay, so let's add a where here to make it a bit clearer. Let's do these now. Let's see what that gave me. Okay, 163 rows, and every time, so it's 163 rows times 1, so it will only look like 163 rows. If it was for some reason, you would have, in the second table, you would have 2, that means you're actually looking through 163 times 2 rows. So if it's like 100, 100, 100, and you have like 4 tables, right, then it becomes very, very slow and you don't know why. So that ideally, when you want to get like one row, it should be like 1, 1, 1, 1, 1, depends on how many joins you do. So explain is a very useful tool. Explain before the select is a very useful tool to see what's going on and like how fast your query is. It can tell you quite a lot. Here, for example, possible keys is very important. Which indexes you have it will use. So basically, what I can recommend you do is you go by this. You see the fact that here it's not using any indexes. For example, in this case it is. Imagine it's not using any index and it's very, very high. You just slap another index to the table, specifically for the well clause or something similar, and make your select statement very fast. So far with me? I mean, it's like you have the keys here. If you see like there's no keys and it's doing really lots of rows, then alarm bells. It's another way of monitoring this. Here you have the different rows that it looks up what possible keys and the keys that you actually used. Sometimes, for example, if you do a range like between this date and this date, it will not use any index, even if you really force it. There are ways around this. I mean, you can obviously, there are ways of making it use an index, but you should always look at this. So explain is actually a very useful tool to optimize your queries. You can go by your slow log and find some ones there. Although the slow log is not just the edge cases, you should go by the ones you'll typically use the most. Okay, moving on. So for any questions? Just stop me if you have any questions, by the way. No. Okay, so benchmarking. Basically, so from your point of view, you have an option of benchmarking the whole application. That means your website. So you can either do Apache Bench or what we use here, Siege. We use Siege here, HTTP load, something like that. And then you make some changes to the database, see if it affects the rest of the website, if you do the whole application together. But if you want to have like something very you want to test specifically the database, so there are some tools which you can do is you can either get a tool like MySQL Slap, or there are some tools that come with MySQL, quite a bit. What you can do if you don't want to get too complicated, you can create a script by waiting for when your site is under load, and you make sure that you save a log file in MySQL database. So you save it to a log file. There's something called MySQL bin log, which converts the log file into SQL. So you have an SQL statement of an hour peak time of your website. Be careful to remove the insults, right? And then you have like a good indication of peak time. What does your database go through? So you run that whole script, go to Nagios, see how it's reacting, and then tweak some things here, try it again. Tweak some things here, try it. You could do the whole application. You could do some scripts. It's not the sum script is not as complicated as it might seem. It's like you just save the bin, you flush the bin before you start. You save the bin, then you convert it. It's a very simple tool, and you save the script and you run the script as often as you like. The thing with whole application, for example, is if you do like a Apache Bench and you get like one page, it's not a really good indication of how your website. You can't really optimize very well for that. You can try and put a few web pages, but if you just do like one image or one page get over, it doesn't really give you a good indication of how to tweak your database. So it's always good to like why it's even running, and you have Nagios on the side, or make a small change. Here you can make a small change while MySQL is running. You don't have to restart, and see if that affected. Didn't affect, change it back. So you can play around with that as long as you have monitoring.
Is there any way of replaying back the queries in sort of real time rather than all at once?
Sorry?
Well, presumably if you did your sort of bin log thing, you'd be
Yeah.
like doing like 50,000 queries as quick as possible.
You
as
would run,
opposed to normally they'd be spread over an hour. So is there any way to sort of get the real life sort of traffic profiling or replay or whatever it would be?
well, I suppose you can get some queries and put them on a cron job or something. Sorry, if you want to do something like that, why don't you can get a tool
Yeah.
and you can write inside the tool the queries that you want to run.
Yeah, but it's more just you if you record like all the queries that happen in an hour,
Yeah.
then you take them offline and do them on your database in the office or whatever,
Yes.
and you run them then, they're all going to run straight away in
That's
perhaps
the-
in
that's
like
the
5
idea.
minutes.
That's the idea.
Well, would you not want them spread over the hour still?
You can do that, but leave it entirely up to you. You can do like,
Because it may well kill the database, if you're trying to do it all in 5 minutes, the machine just might grind to a halt.
Doesn't it do it sequentially?
it does the one after the other. Sorry, did you say it's all in parallel or one after the
No,
other?
no, but well, obviously they'll be sequential, but
Yeah.
they're all still like all at once.
I understand what you're
Yeah.
saying. That is a
Be a
that
bit
is,
more like the real world, as it were.
that is a valid point. What I suggest you do, you can either like take 5-minute intervals and like run that or run it on a cron. It's basically really, I'm sure you got. It's basically really up to you. I would suggest for what you're asking, to do it through an application, or if you want, you can just simulate something like that. If you don't want the whole thing to run, maybe now is a bit excessive, but it does run one after the other. So even if you had one during the hour and then like 20 minutes later, it doesn't run one after the other. Although I would say you'd be surprised how MySQL would handle it. It's still a good indication. I mean, what you're saying is, so it's trying to do one query and then it gets stuck on the next. That is a valid point, but it's still a good indication of what it might go through. Obviously, not, again, in an edge case, again, we're benchmarking to a high degree, but you are right. So I'd leave it up to you. You can split it up or something, do it on a conjure. Profiling, this I think is something you guys might find particularly interesting. So basically, profiling is you're trying to find out like where are the slow parts. So profiling in this example, you would need to do a PHP class where you time something. So for example, you would start the time before running a query. You would end the time. You'd keep it in an array. Sorry, you'd keep it in an array. You start the time, then you end the time, and write some kind of text saying what it is. Then you can save it to a log file, or you can save it to MySQL as well in a table where you can do searches on it. And basically, what you can do is you can profile how long like this particular part takes, the whole page, half a page, this query, the loop of the queries. So in this particular profiling, then you would know exactly what to tweak. So we said, for example, we have slow log here. But slow log is edge cases, like the slowest log. When you might want to optimize for like 80% of your queries. You want to like have an index for that. Make sure that the explain statement for that shows it's very very optimized and very very quick. But profiling here in this particular case, you could do a timer class in PHP and take that out or leave that in depending on you. Any questions so far? Was this like too fast or clear or questions? Am I going too fast? Speaking too fast? Bad accent? No?
It's good. Okay.
It's good. Okay. Okay, so I'll kind of not do this part very, not put too much into this. But basically the idea is to keep the data type as small as possible. Keep like primary keys as small as possible. So you have int, decimal, char, varchar. The difference between varchar and char is var is variable char. So for example, if you have 255 and it only takes 2 or 10, then it will just kind of save it like dynamically on the disk. However, the advantage to char is that MySQL knows exactly how much to give it. The variable is dynamic, so it doesn't really know. So it will be like slightly. And it's not really relevant here. It won't make a huge advantage. Text or blog is something I will talk about. MySQL can handle text and blog, but I think the limit is 2 gigabytes. But it doesn't really like to do it. It can handle it, but it doesn't really like to do it. If you have an option of doing varchar or compressing something which you can compress, and please do so. And I mentioned something about temporary tables on the disk. If you have a table that has a text or blog file and you do some kind of join, it has a group by, and group by will always make a temporary table. So it has a choice: either do it on the memory or do it on the table. And if you have a text or blog column in that, it will always do it on the disk. So even if you want to have like a separate table for that and do like a one-to-one row, that would be better than something like that. MySQL can hide, doesn't really like it. I'm saying that as a general, like as a blanket statement. You can handle it like pretty much fine. But from your point of view, if you want really good speed, then try to avoid using that. If you have to, obviously use it. Enum and set. So I'll have to explain this with sorry about Microsoft thing. I apologize. I know you guys use Linux, and myself as well. So the idea with enum, basically here is that you have something like you can write strings. So for example, let's do this. We have a table customer table. We have the ID, we have the name, and then we have gender, right? So gender here would be, so this would be an int primary key. This would be a voucher, right? Let's do 50. And this would be a enum in this particular case, because enum basically what it says, it's something very specific. So you know that it doesn't only be male or female. So you have like M as a male properly, and female.
We just built an application where somebody wanted a third gender, transsexual.
Yeah, okay, so I'll get to that in a second, no problem. So basically, the idea with enum is that you state, oh sorry, did I spell that wrong? It's because I'm nervous, that's why.
Of us lot.
Anyway,
Okay. Scary.
basically enum is what it does, you see the string there, but it says it like a 0, 1, it's very, very small. It can go up to 65,000, but it can also do 0 to 255. It's very, very small. It gives an option like a list of strings. The idea is that you know that this is exactly defined. Like you know there's only this many states in America, this many counties in Britain. It's defined, okay? And if you want to be really quick, then you could do that. Alternative, what you do is you can have another table, you can have a primary key, then you can have it, then you could change that table to update it. But here, you can change it here, but you have to change it with the outer table. That might be a bit slow. So what you can do is, for example, so let's do transsexual here. You can change it, but you will just do
Transgender.
Transgender.
Sorry, that's
Can I just do she-male?
I have no idea.
Gender.
It's probably
Okay.
suit there.
So what you do, you do an outer table, depending on setup, it could be really slow, but it's a relatively fast way of doing it. That is one thing. I don't think all of you will use enum. You have questions? Sorry, go on.
Just out of curiosity, how would it deal with, say you had male, female?
Yeah.
For whatever reason, people don't like being called male or whatever, they want to be called man or something like that. Would it deal with that? Would you be able to change male to man? Would it realise, or would it break all the data set?
It's a good question. I can tell you this, that in the database it's stored as male would be 0 and female would be 1. But actually, you know what, I don't really have an answer for that.
If you actually try and change the, say you try and change male to man, as long as you keep them in the same order, it will just change the reference. We've done that before with people.
Okay. Set. I don't think any one of you will use enum, but I just think it's cool and you might want to know. Set is similar to enum, but you can do like custom or type. Let's say this. And set, what it will do is do like this. You have like good customer. Okay, good customer. Bad customer. Pays well. And has blue eyes. Okay. You know the fact I'm doing very long. Okay. So what basically set is that you can have more than one variable in there. What you would see is like this. You see ID, name, gender, and type. So what type of customer we have? So we have one, and the name is John, and the gender is male. And John is a good customer, a little bit long, and pays well. Two things. You can have three things, you can have the whole thing, you can have just one. And again, this is stored in 0, 1, 2, 3, 4, depending how many. So it gives you like, you don't have to open your table, you don't have to keep it in like a multi-row. It's something like to consider. I see I've confused everyone. So it's something nice to consider, but I don't think many people use it. Again, it's very quick.
Out of curiosity.
MySQL.
Yes, sorry, go on.
Out of curiosity, how the hell do you tell what would the insert query look like to put that in? Because if I was doing it, I'd imagine I'd quote good customer, comma, pays well, which to me would be like inserting two variables rather than one. So
I think what you do is you do like Oops, sorry. Values. So we will have,
Get him a typing one.
let's say 1, John. You can actually do mail. We'll accept that. I think you do like this.
Alright, okay.
So you know them. I hope I'm on TV now, so I hope I don't make a mistake. You do like that and you close it and close it. Could be wrong. I have to check that. The thing is this: if you do a search for who is good customer, John will show up. If you do a search for who pays well, John will also. If you do a search for customers that pay well and is a good customer and pay, John will still show up. So that's kind of like a nice way of doing.
Can
this
you
thing.
do basic logic within that, so and or etc.
Yeah, in your select statement you can do these things.
But within the set.
You mean if
Or
he is?
would you have to say and type type is whatever or type is
Is this in the set or the select? Sorry, I don't.
in the select in
Yeah.
the where clause? Would you have to do
You can do
multiple bits, or can you put it all into?
You mean in or something like that?
So, say for example, you want to find your good customers that don't have blue eyes.
Right. Yeah. You can do that. Yes, you can do that. And what? Time. Has blue eyes. Sorry, but no. Right.
Is that a MySQLism? Do other databases have sets?
MySQL does have sets.
No, but do other databases have sets?
Oh, I don't know the answer.
Because that's the main thing that puts me off using things like that. Is if ever I need to store.
That's a fair, very fair. There are like data types that exist in other databases. MySQL does not have, or you can do your own data types. But MySQL doesn't have that. That is a valid point. And also, for that matter, if you go into another database, you'll have problems with that. But that was just a cool feature.
Yeah, that's fine.
Okay, moving on, date and time times. The only thing I'm sure you're all familiar with that. Date time is 8 bytes when 7 hours. Timestamp is 4 bytes when 7 hours. The thing with timestamp, it starts at 1970 and ends in 2038, middle of 2038, whereas date time can be 1st of January 001 to 31st of December 9999. Okay? Just let them know. Timestamp, however, you can do the default value to do update current timestamp, and then programmatically every time you update or insert any row, the timestamp will be whenever you update or insert it. So you don't have to do anything with PHP. You can do like time created, time updated, all these things, and that's outside of PHP. So it's quite useful to know, like if you want to like backtrack and see what things have changed or something like that. Signed and unsigned is something I want to get into. Signed, basically, signed means that if you have an integer, then it will be like, integer can be, let's say, tiny int can be 0 to 255. Okay, it's 1 byte. But if you do it signed, that means it can go to minus. It will be from minus 127 to plus 128. And if you don't want minuses, I think 0 and minus. If you don't want 0 and minuses, then what you can do is you can do unsigned, and this is particularly good if I see a lot of primary keys and like they run out of space. You see that it's an int, but you see if you make them unsigned, you just get all this extra space. You don't primary key. Don't need to.
You can use zeros with unsigned.
You can. I'm not sure actually.
You can.
You can. Okay, so you do. Sorry. So the example is, if you want to get more space to the int, or you wanna add more primary key, just make it unsigned, and it will. A good idea to state it when you start, that it should be unsigned. You don't want anything to be minus. You save a lot of space. Some people, what they do is just make the primary key a big int because they run out of space. I think that's the next first thing to do. But when I see it, I try to make it to check if it's signed or unsigned. That is something a quick and easy thing. Null and not null. Ideally, you should have things not null because there's a data integrity issue with that. Only put null unless you know it should be null. Null basically adds another byte, so whatever you had, let's say you have a 4 byte integer and you do null, so it's 5 bytes now, because it's like something or nothing. Null is nothing. It's not 0. It's not a value. That is also something you should try to keep your schema clean and things like that. The signed out of all this table, I would say the text and blob and the signed and unsigned are what you should pay attention to. Procedure Analyze is something nice. I won't actually show it, but what it does is it scans the table for you and tells you the minimum data type that you can have for each column. So if you let's say you have voucher 255, it scans the whole thing. It tells you only need voucher 45 or voucher 44 because that's the longest one in the whole column of the table. So you can save yourself some space. However, don't go crazy with it, because if, for example, you do it 44, then one day you get a surname which is slightly long, then you'll be like, oh, the application crashed. And so, you know, again, this whole thing is like we'll only do like somewhat speed improvement, So don't go too crazy. Just small things here and there. Questions?
So, is there any advantage to having tiny ints as opposed to 1 byte ints?
It's still 1 byte, 1 byte int. You
Are
mean
they-
like int and 1?
But yeah, int and 1.
I think it's
rather than
the same
actually
thing.
tiny int.
I think it's the same thing. No? Okay. So again, like, so, let's say from this, like, let's say the things that are important here are nagios for me. Explain statements are very important. If you have those two things, then you're already doing quite a lot of speed things up. Here, I would say text, signed and unsigned. Procedure Analyze if you want to play around with it, but I don't recommend that much. Also, the nice thing with Procedure Analyze is I told you enums, right? If you have like a column and it has like only 20 different types of strings, it will recommend you do an enum of all those 20. It's like you don't really need to do that. Okay, so choosing the right storage engine. So basically we have MySQL versus Indy. But just the question: who has in the company mostly MySQL? Please raise your hands. Not in front of the camera.
That's how lazy I am.
Okay. Who has mostly InnoDB? Who has mostly any tables? So
Who doesn't know?
who uses
Yeah, who doesn't know?
who uses a mixture of both?
Depending on the customers.
Who knows? Who
So
doesn't know?
why do you decide to use MySQL over InnoDB, for example?
If I can remember to
set
set
that decision.
if I can remember to set it to InnoDB, then I set it to InnoDB. I never don't remember it stays as my ISO.
By default, all the MySQL 5 and upwards is by default InnoDB. So if you don't change it, it will be InnoDB. So the thing with MySQL is that it's the first engine that came with MySQL. It's quite fast. It's known to be fast. It doesn't have foreign keys. Okay. So in InnoDB, for example, if you have foreign keys and you would say, look, so this, whenever you insert something into here, check from another table to see if that exists. It doesn't have that, so it could be advantage, disadvantage. Doesn't whenever you so ideally you would use this table if you only use the table for selects or bulk inserts, right? This table is not transactional. Every time you do an insert into it, it locks the whole table. So it's fast, but if you have a transaction table and it locks each time, then it suddenly becomes not fast. Okay? And also with MySQL, the thing about this that I have a problem with it, if every time you restart the server and it's still working or something crashed, and it was still using MySQL, even if it was just selecting it, the table was corrupted, that's it. Every time you open the every time you restart MySQL, it does do some checks on the MySQL table. Sometimes, especially in Ubuntu, I think it does an automatic check on it. You should really run checks like on cron jobs at night, check and auto repair data in general, as well as in particular MySQL. So the data recovery is not great. That's a fact. Okay. InnoDB, in that sense, it has row level locking. Basically, so when you insert it only locks that row. It has multiple versions of it. So, for example, it doesn't. When you insert something, it doesn't really automatically put it in a table. It puts it in a cache. It puts it in the index, changes it on the index. It hasn't yet committed it to the actual table. Keeps it in a log. That means if you crash the server, it's still got the log. So it's fine. You can also state how long you want the log to be if you want a bit faster, but you run that risk. It does have foreign keys, and again row level locking. So anything transactional would be InnoDB. Basically, by default, if you don't want to guess, just go with InnoDB. Google uses it for the AdWords. There's lots of work being done to it. Oracle, the guy who wrote it is now in Oracle. They use it. Has a lot of work put into it, though because the guy is in Oracle, it's not advancing as much as possible. But again, if you just want to play it safe, the rule would be using InnoDB.
full text.
Okay, so sorry, I did forget. You're absolutely right. Thank you very much. So you have full text search, which you don't have in MDB. In MDB you can have hash searches, right? But you have full text search basically, so it's kind of nice. You can also use things like Sphinx, which is a different engine. But if you want full text search, you can use MySQL. Sorry, I should have actually mentioned that. It's very important. Yeah.
What does that mean to us?
Full text search means that you have, for example, you can bunch together like a bunch of columns and do like, I want to see if this name is in any of these columns, like together. And it will give you a full text search of those columns. Is that, yeah?
I've never really used it like
It's mainly based on with your text fields.
Mm-hmm.
Sort of, if you're trying to search for anything in those,
Yep.
like say for example, you a forum software and you want to search for something within a post, it will be a hell of a lot quicker using full text indexes rather than like queries.
Okay. So,
do you have to do anything to use the full text?
You've got to. I think you've got to just create the right indexes and use the right syntax to actually pull out from the database.
Oh, so you can't just do like.
No.
so full text search. So, like Martin was saying, full text search would be faster on like if you have a big text. You don't know how long it is. Could be long, could be short. The thing is, like with when you do a search, you know, if you do a search and select something where like, and then you do like if it has like percent sign something percent, that's very slow. That doesn't use any index at all. If you do something that starts with percent or word percent, that doesn't, when you do explain select, it doesn't use any index. Whereas full text search will search it better. So I spoke about table locking. Okay, so that was important. But again, so if you don't need full text search, and even David said he doesn't really use it, once or twice I think, then InnoDB is the safe bet. Some more tables I want to touch on. Memory tables is basically only memory. Examples could be keeping sessions, something that you... Oh, sorry. So when you restart the server scratch, even if you restart MySQL, the memory table is empty. Okay, that's something you should know. Example could be like sessions. I'll give you an example that I use. I work in a company that did online hotel reservations. And from the first page, a customer did a search, then it would save the results in a table. And the next page, the customer would read from that table because it was really very complicated searches. It was running very slow, and it was using MySQL, and then I moved it to memory. It was running 20 times faster. It was really very, very fast table, but it's not as, it's like crashes. That's it. So if you want to keep something that you don't really mind losing, this would be very, very fast. Also, when I mentioned temporary tables, you have memory or you have MySQL. So this actual table is what it is, and this table doesn't support text to block. That's the reason. Archive table. Archive table basically it stores files. You can only use select or insert. You can't update or delete. It's kind of like a log file really. And it compresses the data, so it's quite nice. As of MySQL 5.1, you actually do have an index, which is only the primary key. Before it did not. So if you want like bulk inserts and bulk selects, it's pretty good. It's something you should at least know about, especially logging. If you want to log and save it there, and if you want to do like a data warehouse on the cheap, this is quite a good option also.
If you can't insert into it and update it.
You can insert, you can't update. You can delete and update.
Right. So you can't delete.
Only select and insert. You can't delete. No, it's just like a log. But you can.
It's fairly useless about indexes because everything will take forever.
Sorry.
Well, yeah, if you've got a little data in there, presumably you want to query it, and without indexes, it'll take.
Yeah. Well, it was like you do a full table scan or something. It's compressed, so like let's say when the hard disk like spins, tries to grab stuff out of the hard disk, it grabs quite a lot. Then you compress with the CPUs that you have.
Yeah.
So it's not that bad. CSV is basically it's a comma separated value file. Creates an actual comma separated value file. The reason I'm saying it here is, if you have to give a report, let's say you have to give a report, and you have to give a CSV file or like an Excel file. Someone wants to see a report, and you have a table that gets updated every now and then. Instead of generating the whole file and making it CSV file and printing it out, you can do the option of just taking the file from where it is and just going through the website and giving it to the person. So if you want to, you can have a CSV, but it's a kind of a trick, a reporting trick. It's just not too many people use it. If you want, it could save you some time. but from CSV from MySQL point of view, like insert and select, it's exactly the same functions. You just have to make sure the table is updated and just give the file. It's an actual CSV file on the harness. Any questions?
How'd you back up InnoDB?
You mean like, so you can use MySQL dump. You mean like LVM snapshots? So InnoDB, for example,
You just referring to the fact MySQL has like a
You can
file
cover
for
the
each
file.
table,
Yeah.
whereas
Right.
DB can, although it can be a file per table by default, it's still
By default- by
always
default
one big
by default it's
thing.
one. That is correct. You can have a file per table. What you can do is, so what you're saying is LV is snapshots. Like let's say it doesn't lock itself, right? So even while you're backing it up, it still continues to update. Is that what you're saying?
Yeah, yeah, I mean, we used to use I can't remember what it was called, but for InnoDB we used to use a commercial backup tool that
Okay.
cost something like £3,000
Really?
for a license for it,
Do you remember?
so that it would back up live and not shut down.
Okay.
The alternative to that at the time, I think, was just that you had to stop the database and do a MySQL dump on it. Or if you stopped the database, you could actually back up the files, but you couldn't do it while the database was live.
What you could,
I was wondering
yeah.
whether there's anything new. I mean, that's
Isn't
5
there,
years ago. I was wondering whether there's anything new since then.
was that in a basis, DB hot copy?
That's the yeah. I think so.
The thing with InnoDB is even so with MySQL tables, even when it dumps it locks the table and it dumps it. Here it doesn't. It does rollover locking. So even if you take a quick snapshot of the actual files, or you lock the files, and it causes MySQL to crash. So what we do is we do MySQL dumps.
Right.
Okay, and what you can do is even if you start dumping the table and something inserts into it while you're dumping, so let's say a dump doesn't lock up the table. You can still take a dump. Might be a bit cumbersome, but you can still continue using it.
But you'll know you have a snapshot of the table, effectively a snapshot of the table at the time you started the dump.
Yeah.
This is so. What you can do is you can flush the log files, and then for example you can keep the dump file and the bin log. So then you have everything. But if you want to use something hot copy and not stop the website, then commercial software or something, InnoTalk or Smanda. Also, I think it's less money. Although backing up isn't in the scope of this presentation, I'm happy to answer you what I know. Although you seem you have quite a good knowledge already at the end of the presentation.
If you're replicating the database, can you do MySQL dump from the slave? Then you won't have to take down the website.
Actually, if you hold that thought, I'll get the replication up, but I can answer that for you. Okay. Anything else? I can answer that with the replication. Maybe that will answer your question as well. Okay. So we talked about Nagios, and these things show up on Nagios. These are things you should pay attention to MySQL internal. So try, even though it is somewhat boring, try to see what you can get from it. So if you have lots of tables in MySQL, then key buffer is very important. Okay, if you have lots of tables in InnoDB, then InnoDB buffer pool size is important, and key buffer won't be. Okay. Usually, I think the rule for InnoDB is I would say 75% of the solver memory. I think that's the rule to go by. So just give it lots. Basically, what you're doing is sorry.
If it's only a database server, obviously, if you've
Yeah,
got
if
Apache and stuff like that, within
No, just
the
ignore Apache. Just give it as much as possible. So what you can basically the difference with MySQL and InnoDB, what I haven't said is that MySQL saves the keys in indexes, whereas InnoDB will actually save the keys and the data of the columns of the primary keys are. So if you do a select, and you do a select on the data that's actually in the index, saved next to the index, it will be very, very fast. I'm actually learning about it only recently. So InnoDB will have much more index size than if you use MySQL. You should factor that in. But it is kind of fast in that sense. Query cache. Basically, the query cache is like this cache before you even go into any part of the MySQL internals. It's like if it's there, if you ask it before, it will save it there. Then it will give it to you. You bypass everything entirely and gets you a very quick result. If, for example, you say let's say the orders table, and you did like a search on, you did a select on it to save that data in the query cache. if anything after that inserted into the query, into the all those table, the query cache will make that data stale. Okay. I think you should keep that like quite high. You should play with Nagios, see like what you can get out of it. Make sure it's used properly. I'll give you an example of sometimes the query cache doesn't help at all. Was in our data warehouse, we only have like one-time selects and lots of inserts, and it's not useful, so I disabled it. You can just see if it's fast or not. But again, this is something probably very, very valuable for everyone here. Thread cache, basically whenever you make a connection, you make a thread, and this is completely overlooked in MySQL 4. What you have in MySQL 4, this thread cache is 0, and in MySQL 5, thread cache is still 0, but that means unlimited. Completely different. Thread cache basically, so when you make a connection, you make a thread. If the command is already there, then it will just give an answer, and the thread will be released. It'll be quite quick, and you won't have lots of connections, lots of threads connecting to the MySQL table. It will just release them very quickly. On our services, this was very, very useful. I don't even have table cache. I don't have table cache. Sorry. So table cache is like the same principle. It keeps like, if you have lots of open tables, it keeps data information about the tables, and it's not indexed. It's something quite small. It keeps some data and there's lots of open tables. So to avoid lots of temp tables, you can increase the table cache, thread cache, kind of the same in this case. Well, kind of the same, and the higher it is. So sorry. Okay, so the table cache is for when you have lots of temporary tables. To avoid having lots of temporary tables, you can use that. To avoid temporary tables, I'll also explain the next point. Thread cache, when you have lots and lots of connections. If you have 0, so all the connections just make a whole connection, a whole thread. Try to process an answer. If it has some thread cache, it will just answer quickly and it will release the thread. The important part for you is, again, so keep in mind key buffer in InnoDB. The next important part is temp tables. So you saw on the Nagios example that I showed you, we have lots of tables out there on the disk. That means that either we don't have enough memory, space in the memory allocated for them to be in the memory, or they have a text or blob column. We have quite a lot of temp tables on the disk, and I'm trying to avoid that. Basically what you can do, there's two variables, and it's not written, I apologize. It's max heap table size, which is heap and memory is the same thing. If you see like when you do a new table, you have options like heap and memory table are the same thing. So in MySQL 4 it's heap. In MySQL 5 you see heap / memory, it's the same thing. And temp table cache size also. The higher it is, you will avoid writing temporary tables on the disk. And also, just so you know, every time you do a group by, you're making a temporary table. That's just the way it is. So some people, if you just do a select, if you just do a select and no group by, then excellent. If you do, you need to factor that in. Optimize table, you can do that within MySQL, you can do it outside MySQL with MySQL check. So basically I said you can check, you can auto repair and optimize, very good thing. It sorts out the indexes. If you want to speed up MySQL, and if you haven't speed up in a year, you do this command line, definitely you'll see some improvement. So very, very quick and easy thing to do. You just do it at night because it takes a while. Or do it, offline or when you can. Partitioning is only available 5.1. Let me just show you what it does. Where am I?
Is the optimized tables really of any use for InnoDB?
Yeah. So partitioning, basically, let's say you have a table, and this is my table with a capital A table, and let's say you have like all sorts of items. Let's have B, and you have this, and you have, then we have first. Let's see. Okay. Excellent. Okay, let's delete these. So what partitioning does, basically, it separates your tables into several files. So David also said quite correctly that InnoDB sometimes has just one big file. You can do it many files, one file per table. But with partitioning, what you do is you can have like many files on the disk for that table.
That's only of any use if you can put
And you can put the files to this, but I'm just like, for the example here, I just want to explain what it does. So let's say, for example, you run queries a lot on this table, and it's getting quite big and quite cumbersome, and you don't really care about anything before this date. So what you do is you can tell, all this, like all these rows to exist in a separate table on the hard disk, which will be this, and these rows, put it green, will be a different, so it will split, sorry, so basically it will split the table into two files. So you can still see it, if you do a select on all, you'll still find them, but actually when you do a query, you only query like a smaller file on the hard disk, and it'll be much faster. This does need a bit of reading up on, it's not that, I mean, I wouldn't recommend you just thinking it's that simple to do, but if you have quite large tables, then you can use partitioning. Partitioning, as far as I know, can do in MySAM and in MDB, and in MySAM you also have merge tables, which is kind of the same thing here. But the idea is this: so from now on, the things that you do searches most of the time on your website are here. But if you want to do like an all-inclusive, since I started the company, select, you still can. And no effect to the user really. Okay. Any questions? Is this a bit too much? Still with me? Okay, excellent. Okay, replication. So I'll try to answer the question now. So basically, the reasons why you have replication. So let's say you have a website that mostly reads and only a bit of writes. You have a website that has a lot of writes. You want something for backups. You want something for high availability. So there's mostly reads, which I'm going to assume that everyone here is what is interested in. You have a master and a slave, or many slaves. So the slave in this case is read only. Okay, you can't insert to the slave, which is fine because that's probably what you wanted anyway. You can keep as many slaves really as you want. They basically get synced up with the master. When you want to write, you write to the master, and the master will sync up everything. Whereas the other ones, you have a master here and a master then. You insert one, the master has to update the other. What happened if you forgot to? What happened if there's auto-incremental numbers, and this one inserted, and the next number available was the number 10. The other master inserted, the next number available was 10. They collide. There's also a way for that, like just something to basically, if you have most slaves and you don't want to have this problem that you have to take care of, master slave is quite useful. Does anyone actually, apart from our company, use master and slave in their work? No, no one. Okay, maybe one day.
Is it synchronous or asynchronous?
It's like synchronous. Mostly writes for that. I wrote mostly writes, but until then I've been told it doesn't really make it that much faster. So if you have something that has lots and lots of writes, what you can do is, I said there's an issue with auto-incremental numbers. So what you can do is you can do that. All the servers will only add, let's say you have 2. All the servers will only add incremental numbers in an order of 2. So, and the first one will only do something it's the first one. It's all the odd numbers. The second one will only want the even numbers, right? So one server will only do like 1, 3, 5, 7. The other one ends with 1, 3, 5, 7. The other one will do 2, 4, 6, 8.
Surely that means having 2 separate schemas though.
No, same schemas. You just do the auto incremental numbers. You do something in the my.cnf. You make sure that it jumps in twos. In 2 rows. If you have 5s, for example, right? You have 5 master, and you do like 5 jumps of 5. This one does the first one, this one does the second one, this one does the fourth. Then there's no confliction. However, you can't do this in MySQL 4. You have to do 5 and above. Backup. So if you have a slave,
can I just ask, master, is it replicating between the two servers?
It is. So basically, you have both of them are masters, both of them are slaves to each other. So it's like a slave, but not read only.
But it's still asynchronous. So
Still asynchronous, but I think you're worried about the delay if it doesn't show up on another server yet. And that is a possibility. From what I understand, like if it's in the same network, it's quite fast. So it's never. I don't think it was actually something to worry about. Although you are right, it's asynchronous.
Presumably, the worry would be is if you had, say, 3 servers, like 3 masters, then writing to one, you'd have to wait for the other 2 to write as well.
It's asynchronous, but you can make it synchronous if you want to. But then yes, you will have to wait that everyone has the same. So if you do like a select and it hasn't updated yet, it won't show up. That is true.
I believe there's a good example of master, and that is I think it's the train line or something like that.
Sorry?
The train line or something like that. They put a deliberate delay in.
Yeah.
Because their master servers are so far apart, the delay is equal to the time it usually takes for the message to get across the wire.
Okay.
So when you see that waiting in the ticker, it's because they're making sure that both masters are up to date, or however many masters they've got according to the previous system.
Okay.
I just thought they had a crap system.
It's apparently it's quite common on the internet. I think PayPal do it as well, isn't it?
They've also got a
Or
crap
eBay.
system.
Sorry.
They've also got a crap system.
Well,
Okay. So,
API.
so basically, if you have a website, you have lots of selects, you want to speed that up. You can, let's say, you have a really good and profitable website, and you have more than one server, and you want, like, let's say, a third server for the database, and let's say you want 2 slaves on each of your first one. Then you have, local copy. You're doing select. It's all nice. If you want to insert, you could insert somewhere else. So there's, like, you're spreading the load of the selects. Mostly right, I don't think, so I've explained that, I don't think a lot of people work for a bank or anything. Do you? No? Okay.
Yes.
Backups, the reason that I wrote backups is because, let's say you said you wanted to do a dump. So let's say the dump is, it locks your tables, and you don't want it to lock your tables, so you can do from your slave, you can take a dump. You can take a MySQL dump. That's terrible. You can take a MySQL dump. You can actually have 2 MySQLs on the same machine. It's a completely different file. It doesn't access the same files, so you're not locking the same files. And if you want to do a MySQL dump, then it's an option. It's just a bit with Ubuntu. It's a bit tricky, but it is obviously doable. High availability, master. In this case, one master fails, so it's active passive. Sorry, you don't write to one master. It's just there. In case you want to, it fails, heartbeat, move to it, or you just know that it's there, your application knows it's there, so it's high availability. Okay, if your website again works for bank, it's very profitable. Okay, I'm glad I'm not have a sore throat for this side. So basically, application side improvements. So you've all stuck with me up to here, and let's go the part where you might have a lot more influence. So basically, the whole point of this is, apart from the first one, the whole point of this is that you interact more with the table. You think more about interacting more. It's more part of your application than it's just, it's a database. I don't touch it. I use arrays all the time, and I don't want to do anything. Every time I want something, I just write to it and forget that it's there. It's just you bring that in. You consider your database part of your application, and accordingly you speed things up. So the first one would be storing duplicate data, which basically, I should have wrote storing extra. So basically it's denormalizing. Does anyone, do you know what denormalizing means? Normalizing is, do you know what it is?
Mm-hmm.
Yes?
Yeah, I know what normalising is. I don't know what denormalising is.
Okay, so denorm is the opposite of normalizing. What it does is
Well,
that...
yeah, okay, but normalising is a good thing.
Right,
I
this
did
is...
some research on denormalizing
Yeah.
like about 6, 9, 12 months ago, and there were some people that said, oh, it's a good thing, and then they were like, just as equally as maybe saying, no, don't bother because databases are optimized, for normalized relationships, as it were.
Right, so let's speak about it now. So let's say we have, then we have our customer table, we have our ID, we have our name, and this time we have type ID. Okay? Here we have customer type, ID, and description. Okay? Description. Excellent. So, with me so far, you understand how the schema is here, right? You have a type ID here, goes all the way to here, checks if it exists, or like let's say you have 1, 2, 3, and this would be like good customer, bad customer, has blue eyes and all that, but you can only have one for each in this example. And you want to add another description, you can, no problem, you just add to that table, it will show up in that other table. If you have a foreign key, every time you add to that customer table, it will check in that table if it exists, so every time you do an insert, it will do a check. And it's very normalized, so basically what that means, if you want to do a change, the customer type table, it's easy. If you want to, and it's in one place. If you want to, it's a number in the customer table, that means it's not like a long string, which is duplicates, it's not duplicate entries. Let's say you wanted to make a change that you have to update all duplicates, right? So in this case, denormalizing would be just an example, type description. You actually have a duplicate copy from here in here. So you have, this is just an example. So you have another column here where you have the string. Why are you doing this, and what's the point? The point is that it doesn't have to look in another table. It doesn't have to do a join. It doesn't have to look somewhere else. It's all in one table. It grabs the bits of the hard disk and shows it to you. Doesn't have to process anything. Saved itself some time. And by the way, Facebook is very much into it. It very rarely has any joins. Facebook very rarely has any join. It's duplicates that keeps denormalizing.
Doesn't that get to a point where you just have stupidly huge tables?
Look, so like do a bit of normalizing and a bit of denormalizing. Do make judgment calls here. But again, the idea is that you need to understand that if it's in the same table, it's very easy for MySQL to just give you the information, and it's not you don't have to do any inner join statements. It doesn't have to process too many things. It doesn't have to look at another table, join it, do some kind of calculation, and present it to you. It just presents it to you. Okay.
Are you the same person telling us to try and save the bits earlier?
Yeah.
So,
So okay, this is again. I do have to mention that it is if you save the bits, you can do this easily. So it's not a big problem.
I always thought the main thing with denormalizing would be presumably to store some sort of pre-calculated value there.
Okay.
So if the customers have a number of orders or something, rather than you always looking at the order table to find out when they last ordered. Or
Let me stop you there because it's in actually what you're saying. So before you continue. Okay, so we have stored results. So, thank you, David. I continue. No, it's good. Thank you, David. And so what you have a summary table or a cache table. So a summary table would be, let's say you have this calculation, you did this really large group select with inner joins and group by. Takes you 25 seconds to generate it, and you save that in a table, hopefully memory table. Right? You save that in the table, and it's there, pre-calculated, already there. Although your example is a bit different, but I'll get to that. A good example is count in its own table. You have a website. Every single time someone loads first page, it does a calculation. It counts how many visitors ever came to that website and shows you we have 1,000 something visitors. Every single time someone comes, it adds it to the visitor and it displays we had this many visitors since the website started. It's cute when it's 100, maybe when it's 1,000. When you get like to 100,000, it's not funny anymore. It takes a long time to load. Okay. So what you do is you have like your own table where you have your count inside there. If you would write PHP, you would add the value +1 or the value -1, right? Or you would do every now and then, like on a cron job, update this count table, and you don't all the time count the whole table scan over the whole table, right? And do the count. This is a particularly good example of how to speed things up on your website. I think cache table is more towards that. So if you have some kind of summary table would be like if you had like some kind of group by and you did some kind of you want a summary of and you want to keep that summary. And cache if you just want to keep something in cache. I'll give you an example. Something I use. So in the orders table, I wanted to see how many orders were from another country. So every time I do it, it's very easy. I can write select well something ID equals the other country I was looking for. But if I take that, put that in another table, it's much faster than keep doing. And then I join. If I join the top one. Joined with many other tables. So every time it does this calculation, if you just keep that in another table, again, memory tables are good for this. In another table, it's very fast. So it's like a cache of something.
Wouldn't memcache be good for that?
Sorry?
Wouldn't memcache or something like that be good for this?
Well, give you an example of this. So far we have denormalizing, which I think people like found, but it's depends on you. Stored results, I think you understand a bit more. So stored conditions. Okay. So Paul knows this. Oops. So we have let's get another sheet here. It's a sheet. Okay. So stored result would be again customer table, right? And we had. So let's say customer, we want some kind of condition, like let's say paid all his bills. Paid all. This is very difficult. Paid all bills. Okay. So basically, this is a condition. So let's say has he paid all the bills? It's just an example for this. What does it mean? It means you check the orders table, you check the payments table, right? He's definitely paid everything. It's in the customer table. So next time you do, please show me the customers that have not paid all their bills. You don't do the whole thing. You just do You just do on that particular. This would be like a yes, no, or true or false. Okay. So obviously it's like has to change. You need to update it. You need to factor that in that the table is now part of your application.
So it's sort of like rather than having to do loads of nested ifs
Yeah.
within the statement.
It's not only the necessary, it's the fact that you have to go to the orders table, process, go to the payments, this is pre-processed data. It's like you've done the calculation, so then and then like you have a yes, no, so you don't even have to put it, by the way, you don't have to put an index on a yes, no, to no point. So you just do, show me all the customers that have not paid, I want that every single time the account is speaking, right? Every single time I want the select statement to show, and I want it instantly to know that who hasn't paid so I can go chase them up. Okay?
In that situation, when would you update that?
Well, you would have to.
Your application.
You have to. So let's say, for example, if they made an order, let's say you do a cron job at the end and say who hasn't paid within 30 days, 60 days, then you update that. Or if they have paid, you can immediately go there and do yes. Okay. So again, it's more up to the developers now. There's no database administrator. It's up to you guys, and you can make this much faster.
So the whole point of that is to just literally do processing once, read
Yeah.
it lots of times.
Yes.
So you're saving like CPU cycles and
Exactly. And to be honest, like I did say, save the bits on the house, but like you got hard disks so big now, aren't they? You can like save this in CPU, save time. CPUs, even though they are getting cheaper and cheaper, it would be good to save time and CPU and electricity and just save the result. Okay.
So it's greener is what you're trying to say.
Yes.
Planet here.
It is green. It is green. Stored reports.
server off between queries.
Stored
With
reports.
Amazon EC2 you could.
Wake up on plan.
Stored reports I actually have to explain. So you have, let's say you have a report, right? Let's say you have like a day or certain day in the month and the year, but in the same one, like date, sorry. Date, and let's say product that was sold on how many products were sold on that day, and the amount of money made, or the price times product, And so the trick is this: you have an updated column. Remember when I said you have a timestamp on updated, so you don't touch that. You have in the reports that you save the report. So this is the idea, and you generate a report, you save it to a table, an actual, not a memory table, an actual MySQL table, and you have an updated, so you have a timestamp when it was last updated, okay? And you have a timestamp column on the orders table where you want to do that, okay? And the trick is this: every time you want to update this table to have better data, right? You do a search on this table and try to find what's the latest update, the latest timestamp there. Go to the orders table, give me a search from this timestamp here, all the things that have changed since then, and then just like, insert it into it or apply it to it, right? That's the trick. So it's like incremental updates. Or if you made a mistake, you don't trust it. Like every now and then do a cron job just to update the whole thing. If you think you've done it wrong, but you save the report, then like the manager, he wants his report, weekly report, takes 2 hours to run. You've already done it incrementally, just very fast, very very happy, and he wants to do much more. And you've now become the BI person for some unknown reason. Okay, that's all report. So basically, the whole point here is involving database much more with the application. The database is part of your application. Okay, the data is there, and instead of using like what I'm saying is slightly use less arrays and save it there, or save the process. Even if it's like it may seem to be like a bit messy, like don't worry about it. Just try to save some of your results there, and it will be a lot faster. Instead of processing, even if you need to process, you have to get the tape, get the data, process it. What for? You can just do it like that and update it every now and then. So this was the controversial application side improvements.
I assume if you have an awful lot of writes, you don't generally go for those sorts of things. Like if you've got a few reads and lots of writes, you obviously would just calculate a read.
Probably, yeah. If you have like so I'm assuming that everyone here is mostly reads again, and you want to save on your reads, so you do something. But if you're like a bank and transact, even banks maybe. No, actually no. Probably have their own data ware and stuff. So basically, saving up on lots and lots of reads. This is true. Thank you very much for adding that. Any questions? So out of the whole thing, did you find this part interesting? Did you think it will help you speed things up on your websites?
Don't know about performance
No?
at the moment.
Okay.
The de-
Well, you know,
denormalising the bits, you were saying about Facebook. There was
Yeah.
a guy at the PHP conference who was talking about sharding,
Yes.
who was talking about Facebook. And they do a lot of sharding and based on denormalising databases because it doesn't work unless you denormalised because you can't do cross-table queries on it.
To be honest, I missed that, but
So,
I haven't gotten to the level of shouting just yet.
but
You don't want to.
no.
But this is relatively easy. I mean, you can actually have, like, let's say another table. It's just duplicate data, and you just save yourself inner joins. I mean, so you can do inner joins. I don't use denormalizing that much, so I would do inner joins. But in inner joins, you have a table, another table, and the MySQL has to process that. You do one row, has to search the whole table. The row has to search the whole table. So if you have that already saved for them, you can even keep the ID. You just have a duplicate, right? Just to generate things faster. So it depends how much things do. Like obviously you would do it on like pressure points where it's like really slow, and you have to get involved. Otherwise, like the website can't run. So it's definitely an option you can use. Count in this example is definitely a pressure point that you can use. Okay, so last bit. This is a bit difficult for me to explain. Maybe you guys will understand this more. So in the Unix philosophy, anyone know what Unix philosophy is? No one.
I didn't.
You do. Excellent.
I'm
So
not
you-
explaining it.
You're not explaining it. No. So Unix philosophy, as far as I understand, is like a method. The people who wrote Unix have a method of like developing applications in general, methodology, principle. So there's a rule of representation, which basically says fold knowledge into data so that programming logic can be stupid and robust. So even the simplest procedural logic is hard for humans to verify, but quite complex data structures are fairly easy to model and reason about. So basically what I'm gathering two things from this, you tell me what you gathered, by John Bentley's side. One is that if you have like, imagine like a database diagram and you see like, the foreign keys and everything connects, you have some kind of idea what's going on. Whereas looking at code, you have to like really dig into it and start understand what is going on. But in this example, what I read a bit further, I think I'll show you what I think what I think he meant. And basically, it's this. So let's say we take a case statement. So this is slightly pseudocode, so please ignore. Case select. Let's say customer type. Okay. Then we have case pays one. Pays. I'll just do like this. Pays well. Do this. Okay. Case. Good customer. You don't know what good customer is. Maybe different definitions for it. Good customer. Do that. Right. Then you have case. Bad customer. Has blue eyes.
you're obsessed with blue eyes.
Hey, he gets discounts. Has blue eyes. Then you have something like, let's say, case. Good customer. Good customer. And pays well. Then you have case bad customer. You don't know what bad customer is, so I can say bad customer and pays well. As pays well, could be someone that complains a lot. Pays well. Okay. It's starting. It's starting to become complicated, right? So the alternative would be is something like this. So you have, let's say, so I set the conditions. Let's say I said good customer. We should copy paste now. Good customer. Bad customer. Pays well. Has blue eyes. Okay, bear with me for a second. Right, so these are the conditions, and this will be the action. So what I'm going to say is this. Okay, so these are the conditions here. These are like yes, no's, and this is the action. So let's say if a customer is a good customer, let's do this. If a customer is a good customer, bad customer, no. Pays well, no. Has blue eyes, no. Then give 5 discount. Okay. If a customer is a good customer and pays well, and everything else, no. Right? give 25%. Oops, sorry. Give 25% discount.
Way too generous.
Right. If a customer is not, oops, sorry. If a customer is not a good customer, not a bad customer, pays well, has blue eyes, yes, do something, and you go on, and basically you seem to understand the logic here is represented a lot better than the logic here. You know, it's like this can be actually quite long. You do and this and that and that, whereas here is it's quite, you know, there's a path. You can go like, well, how do you get 25% discount? Well, you know, it's there. So if I'm here, you just go through the path, and you know, it can be quite long. This is what I understood from this Unix philosophy. So this is like a way of representing logic.
Is there a maybe bit?
Maybe. I think on yes. I'm sure you can do like, you know, a third, 2/3, or one. Okay. Okay. So thank you very much. Any questions? I hope you found this useful. I think that if you use like one or two things from the whole presentation, then I'm quite happy.
You could just show hardware.
You could just
Yeah,
you could.
or something.
Definitely. That is
Isn't
true.
it this space? Just get a little bit.
One more memory.
Have you tried using that sort of thing?
Build more farms.
I have not, but I realized it's Kazi this so much faster than SATA.